Welcome back. Hope everybody's having a good day. So we are going to be reviewing systems of linear equations. This is something that you should have covered in Algebra 1, reviewed it again in geometry, possibly seen it in pre-algebra as well. I don't know, maybe. So the solution is where the lines intersect. So we have three different types of solutions. If we have two equations here, we could have one solution. That means the lines have different slopes, so they're definitely going to intersect somewhere. And then a no solution means the two lines are parallel, so that means they have the same slope but a different y-intercept. And then infinite solutions means the lines land right on top of each other, so they are the exact same line. So we're going to go through different examples and talk about what might be the best way to solve them. So with this one, you could totally type it in your calculator and hit graph and then look for the intersection point. But we're going to use the substitution method for this. So I'm going to start off here and say, well, we know that this equals y. So we're going to plug it in for y into the second equation. So we're removing, putting it down to one variable so we can solve for x. So now we have 2x minus 2 equals negative 1/2 x plus 3. So with this problem here, we want to get all the variables to one side, numbers to the other. So we can start off by adding, let's add 1/2 x to both sides. So 2 plus 1/2 is 2.5, or 5/2 x minus 2 equals 3. So now I'm just going to add 2 to both sides. Move it up here. So now we have 5/2 x equals 5. So now if we want to get rid of that fraction there, remember all we got to do is multiply by its reciprocal. So we're going to multiply both sides by 2/5. I apologize if you guys hear background noise. I'm at my son's soccer practice, so you might hear some yelling. They'll probably be yelling at my son because he doesn't pay attention to anything. All right, so we get x equals 2. So now to find y, we can use either equation, and we just plug that 2 back in for x and see what we get out. So I'm going to use the first one because I want to avoid fractions at all, if at all possible. So I've got y equals 2 times x, which is 2, minus 2. So that's 4 minus 2, so y in this situation equals 2 as well. So we know these two lines intersect at the point 2, 2. Alright, so let's take another look at a problem here. So this one again, notice we could use the substitution method because we'd say, well, this guy is equal to y, so I'm going to plug it in for y down here. So we have x plus 2 equals x plus 1. So let's get all the x's to one side. So I'm going to subtract x from both sides. And now we have something kind of strange here. We have the variables have disappeared, and we are left with 2 equals 1. Well, that's not a true statement, right? So what does that mean? Well, this means that there is no solution to this because the variable disappeared and we ended up with a false statement. So now, we could have caught this early on if we noticed that the slopes were the same. Both of them have slopes of 1 and a different y-intercept. So that means they're parallel and will never intersect. So we could have saved ourselves some work. Alright, so here's another problem. Yeah, pretty obvious, right? But let's say this one's in standard form, variables on one side, numbers on the other. So we could use the elimination method for this. So I'm going to start off and say, well, if I subtract these two equations, I know those 4 y's are going to cancel out. So I'm going to go 5x minus 1x, and I get 4x. 4y minus 4y, that's 0, so those are gone. And then negative 4 minus negative 4 is 0. So now we got to divide both sides by 4. So now we have x equals 0. So now we have to pick one of the equations and just plug that value back in and solve for y. So I don't know which one you want to do. Doesn't really matter, right? So let's just do the second one. So 0 plus 4y equals negative 4. So we're going to divide both sides by 4, and we get y equals negative 1. So we know these two lines intersect at 0, -1. That would be their solution. All right, so let's take a look at another problem here. So again, this is going to be another elimination that's in standard form. So looking at it, I say, well, if we subtract those x's, they'll be 0. So let's subtract all this. So x minus x is 0. -3y minus 3y, well, that's 0 too. It's weird. And then we got 3 minus -12. Well, that'd be a positive 15. So this looks very similar to that problem we just saw a few minutes ago. This is a no solution problem. If we were to get them in slope-intercept form, they would have the same slope but different y-intercepts. All right, so here's another one that's kind of not in any form, so you kind of have to make a determination on what you would do to solve this. So you want to take a look at it here. What do you think we should try? So I think that this should be put into standard form. That's what I would do. So the first one's already in standard form, so I'm just going to rewrite it negative. 3x minus 4y equals 16. And this one I'm going to add the 4y to both sides. That is a 4y. It's pretty ugly. So now I have 3x plus 4y equals -16. Well, so with this one, looks like if we add them up, the x's will cancel out. So that's what we're going to do. So -3x plus that 3x is 0. -4y plus 4y is 0. And well, 16 plus -16 is 0. Awesome. The girls team just got here if you can't hear them. All right, so we got 0 equals 0. Variable disappeared, but that is a true statement. So that's telling us we have infinite solutions. These are actually these two equations are the same line.